Thanks for joining the Soarcast, where we talk about drones, manned aircraft, and satellites, and how they relate to geospatial products found on the Soar platform. Well, good day, everyone. It's Darren with the Soarcast, and today I have an exciting guest based in Santiago, Chile. And Jose Manuel Lattus is a geologist who specializes in the utilization of remote sensing imagery for the analysis of ore deposits and other landforms, specifically in the science of geomorphology, which is geologic landforms. So Jose has worked in a number of places around the world, whether physically or remotely. He's worked on projects in Chile, Argentina, Russia, Kazakhstan, Turkey, Alaska, and Jordan. And I'm sure there's more to add to that list. And he's also developed some of his own remote sensing algorithms for target identification. And he specializes in remote sensing for mineral exploration, economic geology, environmental studies. And he's also a software specialist in ENVI. And some of the images that he, or some of the sources that he's utilized for imagery include the following satellites: Aster, Landsat, Worldview, 1, 2, and 3, as well as SkyMap50 from Soar. And a little bit later in the discussion, we'll talk about some of his work using SkyMap50. One other thing that Jose does in his spare time is that he's also a professor and lecturer at 3 different universities in Chile. And it's quite interesting. We'll touch on some of the things he's doing in terms of even remote training and working with students in this field and some of the challenges around that. So let's kick off with that. And so, Jose, it's very good to have you on the Soarcast.
Hi, Darren. Well, it's for me a very nice experience to have this interview, also in remote way, and also trying to speak the best I can this particular English.
Yeah, thank you for that, and thanks for staying up late at night. It's early morning here in Perth, Western Australia, and it's late in the evening for Jose in Santiago, Chile.
Yes,
and
it's 9 o'clock, but it's very early. I'm really how you say night man.
Okay, yeah. Well, we in common phrase is night owl. Do they have a phrase in Spanish?
Excuse me?
Do they have in English we have a phrase for somebody who wants to work late or stay up at night is night owl. Do you have a phrase like that in Spanish?
It's like that. It's pájaro nocturno. It's
okay.
Night bird.
Yeah. Night bird. Very good. All right. So, well, I also like to introduce our guests in terms of how we connected, and thanks to the usefulness of LinkedIn, that's often how I connect with people, and I think that's how we connected. We're in a similar remote sensing for geology or mining, I think it is, group, and some of the imagery that Jose was turning out was quite appealing, and so we've connected since then, and Jose has utilized some of the SkyMap50 imagery and produced some incredible images that we'll show a little bit later on as part of that. So it's probably just best to kick off and give a bit of an intro. Let Jose introduce himself. So Jose, I forgot to mention, but you have been working in remote sensing for how long?
I think since 2003. I think so.
Okay.
Yeah. I first do the typically geologist field work from 2003 in Anglo-American. And then I came to the remote sensing area.
Mm-hmm. Okay, so it's quite a long time, and I imagine things have changed quite a bit since you started out.
Yeah.
Okay, so I guess if you can summarize, what are you doing with remote sensing imagery
today?
Yes.
Yeah, today we have I have several projects. The principal area is mine exploration, but in the few last years there is a very high accumulation of environmental works, specifically in salt lakes. I think that's saying the word in English, salt lakes, because
Mm-hmm.
of the care of the water that is in the salt lake, and also the very natural reserves, some birds that we have to conserve, and there's many work that we didn't know we can do with remote sensing.
Mm-hmm. Okay, that's a really good, I guess, introduction to what we'll be talking about in terms of the processing you did on imagery, and it is quite interesting, in some of the scientific articles that you gave me to read up on, in terms of I guess the vulnerability of the environment and the things that are happening in the lithium exploitation. Lithium's under a big demand these days, and even more. And I admit I didn't know that the world's largest reserves for lithium are in Chile. Is
Yeah.
that correct?
Yes, correct.
Yeah, and the area that we're looking at is, and you can of course find this on Soar or on the map, is Salar de Atacama, and there's also a native way of pronouncing that. But anyhow, it's a large, I guess, desert evaporite basin, where there are, I guess, they're lakes that accumulate the runoff from the nearby mountains, and it's quite a sensitive area. It's a national park, and there are species that depend on these areas, and so being able to utilize the imagery for analysis and feedback on the current situation is quite useful. I imagine those areas are quite remote. Is that correct?
Yes, it's very remote. Yes,
Mm,
it's in the Andes, the
mhm,
Andes Mountains near it. It's well, Chile, my country is very thin and very large.
mhm,
So we have
mm,
this from the ocean to the Cordillera, also de los Andes,
mhm,
and
mhm,
the salt flat is near the Cordillera,
mm,
and it's hard to go there. It's not near any city.
mm. Very good. Okay. Yeah. Okay. So before we get too involved in terms of the the processing and the individual imagery and the techniques, I think it's probably a good time to talk a little bit about the remote work, in fact, that you're doing with students. So as everyone knows, the current times. Yeah, every country has sort of different alert or security levels with regards to the virus, and I learned from Jose that Chile is quite restrictive, or to account for this, and so all of the work that Jose is doing is remotely. So whether it's his consulting work with SR GIS, or as a professor, is all done remotely. So, Jose, maybe you can tell us how do you go about teaching somebody remote sensing analysis from a remote location?
Well, it results that this remote learning is very efficient. So because
Mm,
when we were in the classroom, I do explain with the software and the PowerPoints, and we have as 30 students with each with one computer, and and if you say something and they don't get the idea, many students let the go,
mm,
and now, well, the politics of the teaching, the remote teaching, is to record all the sessions, and the students have all the sessions recorded. So it's like have and generate many YouTube tutorials, and they all have their computers, the software, and we connect remotely. I do my slides, my PowerPoint, and step by step, very slowly, I teach how to move the mouse, where to click, where to open, the file to open, and even I'm explaining, and it is an experience, very interesting experience.
Yeah. Well, I think I just wanted to point out that it's things are achievable in this environment, and especially those of us who have sort of a technical focus. The resources are there so that we can tie into those and get the information. So I wanted to sort of allude to that because that's often what that's sort of the service that we're offering in terms of collaboration and sharing and generating an interface where anybody can use a map and gain information from that. So let's transition a bit. So aside from the instructional and work you do for the universities, you're also consulting as you mentioned, in the environmental and also in the exploration. Who are the clients? Who are the people that are I don't know, supporting this work?
Principally, there are mining companies. The principal is in metal and in non-metallic or metallic. The copper, gold, silver for one, and lithium, for example. And some little environmental consultants, but I think principally they are mining companies.
Mm-hmm. And so these mining companies are utilizing your imagery and your processed imagery to do effectively to do what? What types of images are you giving them, and what are they then doing with those images?
Well, the principal images are aster images. Because of the information in the shortwave infrared, we can detect some special minerals, and these are used for exploration. So still now, all companies are exploring for new gold, copper deposits, and we use these images to help to find new targets, to minimize the area that we will go to the field, and things like that.
Mm-hmm. Yeah, just one question. So one of the people that I sort of follow on LinkedIn, he's very active in the and I think it's sort of more just a hobby for him, but he's very active in identifying abandoned or disused, discontinued mines. So mines shut down because they're not economic. The price of the commodity fluctuates, and so they have to shut these. This is in South Africa, and so they shut these mines down, and the mines are in various areas. Just out of curiosity, is there? So I, as people would sort of in this industry would know that you have exposed geology at the surface, and you can use the imagery to identify minerals by their I guess reflectance, and but of course there's sometimes there's topsoil, or the minerals that are at the surface have been weathered over millions of years, and so they're slightly altered. And I guess, do you have much? So, do you have much occasion to actually come back and perform analysis around areas that have previously been in production but are now abandoned? Is that part of the things you do?
Well, I do process the images. I never go to the field, okay? Because my work is for mining companies, and they take my work and they use, and they're very jealous about the information. So I do not have the opportunity to check if my process is going well. But I think that if they call me again, it's because the process is success. I don't know if
Yeah.
that is the question that you asked me.
Well, I think so. I mean, you did answer. So that would be you did answer the question. So that would work in very active, mining. So open pit mine where they're continually developing the mine, and maybe annually, or every couple of years they would bring in services like yourself to just do an aerial analysis. I was thinking about even cases where, for example, the gold is a commodity that a slight fluctuation can bring in new exploration, because suddenly a mine becomes economic. The cost of the gold is high enough so that the cost of production isn't higher than than the actual cost of the ore. So the question was a little bit more focused, and just it was personal curiosity, to where that people have asked you to look at an old mine that isn't in production, and do some analysis. Of course, they don't tell you, how much money they're going to make. But has there been an occasion where a mining company has said, "Can you look at this old mine for us?"
Yes, yes. It's very common. It's very common to do this. Many companies have the mining property, and they trust the mining property, and another company takes the same mining property. So the new owners of the property do not have access to the information of the other companies. They don't buy the company. They just buy the land. So they have to reinterpret the information, do reinterpretation with new information of the field, and I process some places like 3 or 4 times the same place with new information. Yeah, because there is in mining there is a very precise sentence that is that the information is that put the price in the property. More information, more valuable.
Oh, I like that phrase. Okay, so I want to give people that are listening today a sense of how big the projects you're working on. I suppose it can vary greatly in size, but we want to give people an idea of the scale, or the actual resolution of the things that you're looking at. So, for example, the imagery that you utilized, our own imagery, the SkyMap50 imagery, was an area of probably 150 square kilometers, which is quite a big area, but not really in compared to the basin that it was a small chunk of Salar de Atacama. But maybe you can just give us some examples of say the smallest project and then the largest project you've worked on.
I think the smallest project are like 25 kilometers cuadrados. I don't know how to say 25
square. Yeah.
Kilometer square.
Yeah.
Okay.
Yeah.
Is the smaller area, but this is when you have many other studies in the area. No companies start with a 25 kilometer square a remote sensing study. They start with a very large area like Landsat, like 200 kilometers, 200 for 200, or even a complete region, or all the northern Chile. I'm processing now, for example, like 1,000 kilometers in the North House, and in the wide, I suppose 300 kilometers or 400 kilometers. And then you have free images, and you process, and you get some targets. And in the targets, it's when you go to the Worldview 3 and process 25 kilometers square or 100 kilometers square. It's when you have more information of the project.
Okay, thanks, Jose. I think that's you made a good point in terms of, and we listed off some of the satellites that you've worked with. So, for example, you mentioned Aster and Landsat and Worldview. But for Aster and Worldview, what is the resolution for those?
Aster have 50 meters in the visible and near infrared bands, but the short infrared are 30 meters like Landsat. Then you jump to Worldview 3 that have in the visible near infrared like 1.2 meters. and in the shortwave infrared is 3.75. And you have the free images with the better spatial resolution is Sentinel that have 10 meters, the visible and near infrared.
Okay. Yeah, and I think that's that also brings up something that's quite, I guess, interesting and also relevant to what we're talking about. And we've made mention of resolution, and then we've made mention of bands, and for those who come from sort of maybe drones where they're not working with multispectral imagery, or for people probably who haven't experienced these images. Maybe you can just explain what are you talking about when you mention bands? When you mention things like multispectral and infrared bands, what does that refer to?
Yeah, well, many people say that why do you don't use a drone and fly and get the better image? I say it's quite different when you have the phone camera or the phone camera or a RGB camera that have only just take the visible information, the same information that our eyes see. It's like Google Earth. You have Google Earth with many images with a very high resolution, but it's just visible information, the same that the human can see. But the images, the multispectral images, have information in wavelengths that the eyes cannot see, and some information of the materials of the surface are invisible in the visible range of the spectrum. So with this multispectral information, we can see more than we can see with a normal camera.
Okay, yeah, I think that I think you definitely gave a good overview of that, and that is really a lot of what I think that you're doing in terms of the stuff that's either I guess lower wavelength than visible light and higher wavelength than visible light, that the type of things, like you said, that our eyes just can't see, but the sensors can pick those up. And the other thing that I thought would be good to mention is that, in fact, maybe even I'll use a Sentinel satellite, for example. Sentinel satellites have, in fact, 12 bands. Sentinel-2 has 12 bands of capture, of electromagnetic light capture. So there's your three, red, green, and blue, and then there's also infrared. And then there's a far infrared, and then as well they have a ultraviolet light as well. And what we're saying is that this light is actually broken up into sections, and then gentlemen like Jose take those bands, if you will, those parcels of the spectrum, and build algorithms to reveal whether it's minerals or some of the other exciting things like bathymetry, the ability to tell what the water depth is from. I know that Sentinel satellites are almost 800 kilometers up. It's quite interesting to talk about that, and so we might actually move more into what you've done, and we'll use the example of the SkyMap50 imagery over Salar de Acama and the lake Laguna Barros Negros. Is that correct?
Barros Negros, yes.
Barros Negros, and that is, I believe, that is a national park. That part of the desert. Okay,
it's a national park inside the Salar de Atacama.
Okay, I understood. So maybe we've talked a little bit about the lithium exploration in the area, but just because we're talking about imagery that relates to what's going on there, maybe you can just describe sort of the lithium in place, how it's there, or in what form it exists, and how it's processed, and then furthermore how your imagery relates to all that.
Well, the lithium extraction in the Salar de Atacama a very you see some pools in the salt flat. These pools are where the lithium are processing, and to generate these pools we need the water, and the water became from the all parts of the salt flat. So we have these natural lakes, Barros Negros, Chaxa, and others, and the authority, politicals, are looking if the mining company get water from those lakes. So we have to monitor the coverage, the depth of the lake, so to be sure that the equilibrium in the salt flat is all years is okay. That's the final sentence. We have to we do monitoring of the water in the salt flat. Salt
Okay.
flat,
Yeah.
the word
Salt flat.
salt flat. Yeah.
Yeah. Um, yeah. Okay. And I want to speak a little. So, what the SkyMap, like other satellite sensors, can acquire both the visible light and then also the near infrared light. So the light that's just outside of what you and I can see. But there's quite a few things that the near infrared can be used for to assess vegetation and then also help in the, I guess, classification. So it's yet one more component that allows people to build, I guess, processed imagery that people can utilize. So I made mention of the water depth over this lake, and as I mentioned, you're giving us the depth in this lake from a satellite image. Can you tell us how that happens?
Yeah, well, I take this information because we are studying the salt flat many years ago. So we are continuing investigating about indexes and papers that the scientific community publish. And the 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 light when you have some different wavelengths, when you approach to the ultraviolet, you have a very more penetration in the water. So if you have one band with a low penetration in the water and another band with a better penetration in the water, you can see deeper, and you have some like two variables, a deeper and I would say shallow, no? Deeper and shallow.
Mm-hmm.
And with the two bands that reads differently, the deep, you can make an index to extrapolate information and to map a relative depth of the water. It's not a, how to say, absolute deep. It's relative. Mm-hmm. Here it's more shallow. Here it's more deep. Mm-hmm. And there are very interesting works using this information to generate in places that you have lakes or waters not so deep. Okay, not so deep and clear water.
Okay, yeah, no, that, and I guess with that, as you mentioned, it's a relative depth, so it's what is shallower, what is deeper. But you would be able to index that against field values. So if you went out onto site and gathered a relative sample, across the whole spectrum, the deepest parts and the shallowest parts, not the entire lake, but if you had a correspondence, you could build a depth model based on that. Is that correct?
Yeah, that's correct. Yeah.
Okay.
You have to just, when you have the image, you have all the information, the soil and the water. So if you process all the information that you can get is very limited. But if you focus just in the water, you can get much more information. Deep, maybe, I think, contamination. It depends on the wavelength or the band you have. For deep, it's use the penetration of each band. Okay.
Well, part of the Soarcast is that we like to engage our users and show them how to get more value out of the data that they're using and that they're sharing with clients. So let's check in with the folks from Soar about how the Soar platform is servicing your needs.
So what is Soar Plus? Well, imagine if Google Earth and Dropbox had a baby. Soar Plus is the premier solution that allows users to store, view and share maps and imagery on one simple mapping platform. Think of Soar Plus as your own digital atlas. Find out more by visiting us at soar.earth.
So welcome back, everyone. Let's pick up where we left off. Let's move ahead in terms of some of the other imagery that you generated from the SkyMap50 image. So this is a 50 centimeter resolution image that consists of red, green, and blue, and also near infrared light. And from that imagery, Jose has generated the bathymetry image, and as well soil humidity, and so we'll speak a bit about that, and then also a soil classification. So maybe we'll speak about the soil classification because it also relates to the humidity. So again, like you described, how you take an image that shows a picture of something from Earth, from space. We look at something that's a picture of, well, the desert, and we see a lake. But from that, you're able to generate what the soil types are around the basin. So how do you take the imagery that you could acquire from Soar and then get it to the point where it is a soil classification map?
Yes, for example, we do the soil classification. There is an equation that I read many years ago that tells that if you have a number of bands in your image, you can generate the n+1 a different information. So if you have as 4 bands like Soar, you can generate at least 5 different kinds of materials. You can identify and map 5 different materials, maybe more if you have more field information. Because the materials have a spectral signature, that one material from another have different spectral signatures. So the software and helping by the user detect the difference in the spectra with the 4 bands. We need the multispectral information, and for example, you have the red, blue, green, and the near infrared, and you have a spectral signature that is going like, for example, near is higher than red, and another pixel have red higher than near. So there are different materials. So you do the software to check into the matrix of the information and solve how many different spectra you have in the soil, and then you get the information and go to the classification, and it's you can interpret the information and you see the colors, and you can have a very good map of the use of the soil.
Okay, and what are the so you've got, we'll show an example. We'll show that example of the soil classification that you've generated. What is the end user going to do with this? So I suppose there's both environmental uses and there's also geologists. So what would an environmental scientist do with that information? Then what would a geologist do with that information?
Yeah, I think for environmental is not very useful in this case of soil classification. I think for environmental is better for the moisture index. But for geological, there are in the salt flat you have many kinds of minerals, and it's very useful to know which minerals they are. With the image, we cannot tell which mineral is, but we can tell that there are two different kinds of minerals. And with the geologic interpretation, you can see this is salt, this is halite. I don't know, the alita is the name in Spanish, and this other could be gypsum, for example. So with the soil classification and the field interpretation, you can map different zones of the salt flat, and that is very important for geologists, for the dynamic of the salt flat.
Okay, yeah. And I think that's one more thing. So you mentioned the soil humidity image as well, and that is also through similar, I guess, processing techniques, you're able to resolve the relative humidity in soils, which was quite interesting for me. Why would somebody want to know relative soil humidity?
Yeah, the relative soil humidity is different than the classification, because we use a particularity of the humidity of the moisture, that when you have more humidity in the soil, you have less reflectance in the near infrared, near infrared bands. So the water or the humidity is higher in green and go lower to the near infrared. But if it's much lower, the near infrared is more humidity. So we use that information to calculate the relative moisture of the soil. And why it is important? Because they think that in the time we have to monitor the humidity of the salt flat, because it's related with the water down the surface. I don't know how to say. When you have here we say in Spanish es el agua en profundidad, the water down the surface. Okay.
Yeah.
These have an information that you can see in the surface, so you can check if the salt flat have an equilibrium year by year. You have to study this moisture index year by year, not just one image. Not very useful to calculate the moisture. You have to check if the moisture is stable in the time, or you are losing humidity.
Okay. Well, very, very good. It's all quite interesting, and it's been great. Partnering with you, Jose, to process those images and yield incredible information from them. And all of these images that we're speaking about are available if you were to just find the Salar de Atacama Basin in Chile. The images are there on Soar for you to visualize. And so, from the team at Soar, Jose, I just wanted to say thanks for your time and thanks for all the great information that you've given us.
No, thank you for the interview. I think that I could explain 3 times better in Spanish, but I do my best.
I think it went off very well. So thanks, Jose, and thanks everyone for joining us on the Soarcast today.
Okay, thank you.
That's all we have time for today. Tune in to our next Soarcast for more discussion on geospatial products found on Soar.